Welcome back at C Square. In this lesson, we will discuss about uh, proportionality, and we will see that we can use proportion also for other segments of a triangle. And I said here the one that you know about altitude bisectors, angle bisectors, and medians, right? So let's start with the beginning, which we discussed already. If we have two similar triangles, like in this case, then we can write this extended proportion, how it's called. But then, like I said, we can extend this property to, for example, the altitude. So in this theorem, you see here, I said if two triangles are similar, the lengths of the corresponding altitude are proportional to the lengths of the corresponding side. So let's take a look. You see, these are the altitude. We can notice in the picture those two altitudes, BE and F, follow the same extended proportion. So if you want, you can look to this statement and this statement, and you'll see it in some problem. I'm gonna kind of combine these two statements. Okay, so let's take a look to two more theorem, and this is one of them, which is covering the angle bisector, the same type of property. If we have two similar triangles, the angle bisector are proportional to the lengths of the corresponding sides. Okay, so again, kind of the same thing, and remember, we have that extended proportion. Sometime you're gonna need to use that extended proportion for solving the problem. And the last theorem, very similar with the other two, it's obviously covering the last special part of a triangle, which is the median. And the medians are also proportional in a similar triangle, into similar triangle with the lengths of the corresponding sides. So you can see that in my statement here. Now, it's very important to recognize also angle bisector sometime, right? Look at here, these two angles are congruent, these two angles are congruent, and medians. So recognize eventually in your picture the type of special segments you have in your triangle. So now let's see the first example. We have these two triangles. They are similar. Remember, this sign means similar. Find NF. So I'm gonna call it X. If BE is 6, AC is 9, so the whole thing is 9. And then MT it's 12. So we can write, we can use the first theorem we discussed today. Okay. If you remember, we had something like BE over NF. We can write it like this. It's not the only one, by the way, equal AC over MT. Okay, and probably in this lesson I'm gonna write this proportion in different way just for you to be familiar. But you need to be consistent. You see, I start with BE, small triangle. You can start with a big triangle, and then I move in the big one, NF, and then 9 small triangle, MT big triangle. So be consistent. I'm gonna say that again. So again, we're gonna replace with what we have. 6 over X equals 9 over 12. I'm gonna do cross multiplication. So we're gonna have 6 times 12 equals 9 times X, or 9X. And I'm gonna divide by 9 here. And we have 6 times 12 divided by 9. We can grab a calculator, or you can simplify. 9 is divisible by 3, so 9 divided by 3 is 3. 6 divided by 3 is 2. I can do another division here. 3 by 3 it's 1 and 12 by 3 it's 4. So x will be 8. Of course, you can grab a calculator and do the math. So in fact, let me be sure, NF is 8 because that's what x is. Okay. The very next example, very similar. Please, like I said, recognize we have what here? We have angle bisector. So you can see BG and NH are angle bisectors. The triangle are similar. So what can we write here? First of all, let's read the problem. Find BG, call it X. If AC, again, the whole thing here is 18 and NH is 24 and MT is 27. Okay, so let's start small. Triangle, and I grab the X and I can move and do this 24. Equals, going back in the small triangle, 18 over 27. So I move directly to the proportion that you can use to solve this problem. So we have here 27 times x equals 24 times 18. I'm gonna divide by 27. And I have x equals, again, let's try to simplify, but of course we can grab a calculator and do the math. 27 divided by 9, that is 3. 18 divided by 9, that is 2. And 3 goes in 24 8 times, so 8 times 2 is left, so 8 times 2 is 16. That is how much BG is. Now, whenever you finish this type of problem involving proportion, you can go back, replace the x with the value, and see if your answer is reasonable. Let's move to the next example. What we see again, the two triangles are similar, and we have what we call medians. If you notice, we have these congruent parts. So R is the midpoint, P is the midpoint, so BP and NR are medians. So now we can use pretty much the same theorem, but let's read the problem. Find BP, I'm going to call it X. If AC is 24 and R is 26 and MT is 30. So I can write pretty much the same proportion like the other one, but let me show you a different way. Maybe you want to start to still with X. And let's say you start with this X and then you say, hey, 24. That's okay. You write a ratio involving only the small triangle. Now, on the second ratio, you're going to be consistent. So we're going to have to write here 26 because that is the corresponding part for X, and 30 because that is the corresponding part for 24. So another way to write the proportion, no problem. By the way, if you write the other way, X over 26 like we did, that's okay, equals 24 over 30. Either one is good, and if you cross multiply, either one is going to give you what? 30 times X, 30X equals 24 times 26. I'm going to divide by 30. So now let's take a look. 30 and 24 we can simplify here by 6. 30 divided by 6 is 5. 24 divided by 6 is 4. I don't see any other simplification possible. So we have 4 times 26, that would be 104 over 5. if we do here a division to 20, right, 0.8. I hope I didn't miss the division. So that is how much BP is. BP will be 20.8 or 104 over 5. Okay, so again, I want to emphasize different ways to write proportion. Just be sure you are consistent when you write the proportion, and then when you finish the problem, check to see if your answer is reasonable. In the last part of this lesson, we're going to talk about what is called the triangle angle bisector theorem. And this theorem involves also proportionality. Let's take a look. This is the theorem. An angle bisecting a triangle separates the opposite sides into two segments whose lengths are proportional to the lengths of the other two sides of the triangle. So let's take a look what it says. Again, notice we have one triangle now. This is about one triangle. These two angles are congruent, so obviously we have an angle bisector. And what the theorem says? If these two angles are congruent, angle bisector, then AB, which is this guy, right, over AD, do you see this is adjacent to AB? So AB over AD is equal to what? BC over CD. So that's what this theorem said. So there we have a proportion there. So let's see how we use this theorem. And we have this triangle ABC, and again you should notice that we have angle bisector. So I can write AB over AD equal BC over DC. Now, let me emphasize again, this is not the only way you can write this proportion. There are some other ways, but now let's use this one. Let's see, AB is 6, BC is 12, AD is 3, and we need to find DC. So we're gonna have AB over AD 6 over 3 equals BC over DC 12 over X. Again, cross multiplication here, 6 times X equals 3 times 12. Gonna divide by 6 to solve for X. Again, we're gonna simplify here, but the math is not super complicated. 6 goes in 12 2 times, so we have X equals 3 times 2, which is 6. X being nothing else than DC. And again, like I said in the previous problem, take a look if your answer is reasonable. In this case it is. You notice this 6, the picture is pretty accurate. Should be more than that AD, which is only 3. Okay, let's take a look to one more problem, very similar. The only difference now we have some expression there. In the figure below, Rm is X, so again I'm gonna mark it X, Ma is X plus 1, As is 15, and Rs is 18. Okay, again we notice we're talking about an angle bisector because these two angles are congruent, so we can use the angle bisector theorem, which says let me write this in a different way, just to show you that you can write in a different way. So the first way, it's exactly what I did in the previous problem. X over X plus 1 equal 18 over 15. That is one way to do it, which is pretty much what I put in the theorem. But also you can say, hey, X over 18, so the sides of the triangle, right? And then those two parts, but be sure you match them, right? So it should be x plus 1 here. You match with the corresponding parts over 15. Either way will be good. Just be consistent. I'm gonna say one more time. And here we have cross multiplication on either of these proportions. So we have 15x equals 18 times x plus 1. Distributive property here. And we have 15x equals 18x plus 18. And I think we end up with something that I really do not like, but we'll see it in a moment. Let me double check if I copy the things correct. Rmx, x plus 1, as 15, rs is 18. Yeah, I did copy correctly, but we're gonna end up with a negative answer, which doesn't make sense in geometry. I apologize for this. So yeah, probably I should have subtracted 18x, make more sense like that. And we have negative 3x here equals, that's the reason I said it doesn't make sense. I apologize for that. X equals negative 6. We should get something else. Let's make this one x minus 1. Okay, so let's go back here and hopefully it's gonna make more sense now. X minus 1. So then we have x minus 1. I hope that will work better. Rs is 18 and As it's 15. So x over x minus 1 equals 18 over 15. So we have here 15x equals 18 times x minus 1. We have 15x equals 18x minus 18. So I think, yeah, that this one makes sense. We subtract 18x here. So we have here negative 3x equals negative 18. Divide by negative 3. And we have x equals positive 6. So like I said, it should make sense. So we need to find the value of x, which we did, and round to the nearest tenth if needed, is not needed. But now let's give a meaning. That's the reason I said that negative 6 doesn't make sense. Rm should be 6. Am should be 6 minus 1. And that'll be 5, just in case you need it. Okay, but this is what we need. This is just going one more step just to see. This is 6, this is 5. Does it make sense? If you take a look to the picture, I think it does. And one more time I apologize for the initial mistake. And the last problem in today's lesson, very similar. We notice we have an angle bisector, so I guess we can use the same theorem, of course. The perimeter of triangle ABC is 105 units, and BD bisect angle ABC. We see that in the picture also. Find AD, so we need to find this X, let's call it like that. And DC, I think I will call this X then, because it's smaller. Okay. Or maybe let's wait a little bit. If AB is 48, and BC it's 12. Okay, so yeah, if we call this X, then we don't know how much this AD is, but AD will be, this AD will be nothing else than BC minus DC. So if we can find BC, which I think we can, right? Then we can write an expression for AD. So that's going to be my first step to find BC, and I'm going to start from this perimeter of 105. The perimeter of the triangle ABC means AB plus BC plus AC, and the perimeter is 105, so we can write 105 equals AB, it's 48, BC it's 12, and AC is the guy we need to find out, like I said. And you see here I should have said AC, not BC. Okay, so we have 105 equals 60 plus AC, subtract 60, and we end up here with 45. So now we do have the length of segment AC, it's 45, so obviously AD now will be that 45 minus x, right? 45 minus x. So I think now we have everything we need in this picture to write the proportion we need by using the Angle Bisector Theorem, which says 48 over 45 minus x. So you see how I match them, very important, right? Equals 12 over x. So we're gonna do the cross multiplication here. 48 times x equals 12 times 45 minus x. Let's do the distributive property here. I'm gonna move right here now. 48x equals 12 times 45, that is 540 minus 12x. Again, we're gonna solve for x here, so I'm gonna subtract 12x. I'm sorry, I'm gonna add 12x. So we end up here with 48 plus 12, that will be 60. X equals 540. A last step to solve for x is to divide by 60. And we end up with x equals 9. I think that's what we are asked to find. No, we are asked to find AD. Okay, and DC. So this is 9. This one will be 45 minus 9, 36. Oh, AD, it's 36. Of course, now at the end you can take a look and see if this makes sense. And if you notice, 9, 36, you can multiply by 4, right, to get that 36, 4 times 9. 12 times 4, it's 48. So, yeah, the answer is reasonable. That is, like I said, one of the things you want to do at the end. If you enjoyed this lesson, don't forget to click the like button and come back on C-Square for more help. Thank you.